Welcome back, Eigen family. Like, share, comment, subscribe, all that good stuff. Check out Eigenbros.com, Eigenbros on Instagram, Eigenbros on Twitter, Eigenbros2 on TikTok. And then patrons, thank you guys once again. We greatly appreciate it. We greatly appreciate the support, guys. If you want to join our Patreon, it's patreon.com/Eigenbros. Me and Juan will do a 30-minute podcast, audio podcast there every week. We also have Discord access as well, and then some other things, hopefully here and there as we move along. And yeah.
And I promise you, there's no Discord in our Discord.
Brilliant joke.
Anyway, folks.
Anyway, yes.
Anyway, hopefully that made you laugh, and you're like, okay, you know what? Maybe we'll give these guys a try. But
or we lost patrons. Just
now. No, well, I'm saying new listeners. For those of you that might be joining us because maybe you're out there searching the internets. And you haven't really found a distinction between, maybe should I take the physics route or the engineering route?
Right. It's a big choice. An important choice.
Yeah.
One I've contemplated myself.
This is literally...
I mean, you have too, I'm sure, right?
Yeah. As for some of you that don't know and are new listeners, me and Terrence and I, this whole channel is us two physics guys, doing the whole physics thing, covering physics subjects. And so we thought, hey, maybe this is like application cycles like about to come to an end, and some people are making some really important life decisions.
Indeed.
That are going to be very lasting.
Well, don't scare them too much,
right,
because they're not,
You're probably young, so, hopefully this will be informative and useful.
Don't get scared away.
Yeah.
Hopefully
you'll find this very useful and interesting.
Especially if you're American, this is the land of opportunity. You can always switch around and do what you want.
Very true. If you're from a European country,
good luck.
It's too late for you.
Yeah.
Run. No,
Just kidding.
Just kidding. But anyway, so we decided we're going to use MIT's. What was the catalog? Is it the course catalog?
Yeah, course
right?
catalog, I guess they call it.
Yeah, so if you're an undergrad, you probably already saw the course catalog. If you're applying to schools, you probably already, or should have probably already looked at their course catalog for what their program looks like. I mean, I certainly did. Did you?
For the schools I was applying to for undergraduate?
Yeah.
No.
Yeah, I didn't either. But should
for
I
undergraduate,
have?
I didn't give a shit as much.
But should I have? Yes.
Yeah. I was not a good student for a very long time.
Well, knowing what you know now, would you recommend it?
Yes. Yeah, I would.
Yeah.
I would.
And that's because you get to see the rigor of the program, and that's one of the reasons why you would want to see if engineering or physics is the route, because physics has a lot of math. And we will compare it to engineering and see what it looks like. So out of all the engineering, we have aerospace engineering, and we're going to focus on more of the closest to physics.
Yeah.
Aerospace, what else do we see here? We have computer science and engineering, electrical engineering.
Classic.
Yeah. Classic engineering, just regular engineering. And
materials science engineering.
Exactly, yeah. And then mechanical, and then nuclear science and engineering. So quite a number of engineering.
Yeah.
How come they don't have different kinds of physics, Terrence? No, they actually do.
Well, they do. It's just that we don't get that much of a
in undergrad,
branching.
No. By the way, in undergrad, you won't see this kind of differentiation. There's not degrees
in physics.
Yeah, in physics.
No.
There's just one.
Yeah, technically,
physics.
that's kind of interesting. Yeah, that people may not know is technically, in undergraduate, you're really just all general physics. But that's not really in reality, because if you're doing research, like I did research in undergraduate, I was kind of already in condensed matter at that point. But it was unofficial or off the table, It was not like part of my title, like in graduate school where I was a condensed matter physicist.
Yeah, same here. I took like classes in SEM stuff, TEM. I took a microscopy class. So,
but you also did research in condensed matter? Or? Okay,
yeah. But that's
so
the
we
thing,
were like already in that path, even undergraduate.
Exactly. Yeah. But you'll still have the title as physics undergrad. That's kind of the point we're making. In physics, there's no differentiation just yet.
Mm-hmm.
And if there is a differentiation, it'll probably be thrown under the umbrella of applied physics.
Yeah, exactly.
Yeah.
Yeah. Or the other one for my school was also physics instruction, or like physics education.
Oh, physics education.
Yeah.
Right. True.
They had a specialized track.
Right. There's also astronomy.
Yeah, that's true.
That has its own course, which some people might not consider physics, but a lot of departments just lump them together anyway.
Yeah.
So if you're a physics major, and are only focused in astronomy, your courses might look different. So
yeah,
just so
they'll diverge a little bit, but you're still taking all the same physics courses that any general degree is going to take.
Yeah. So which
the
one?
Core, at least.
Yeah. So which one do you want to dive into first? We should to compare. Should we
just go down the list?
Aerospace.
Yeah. A is for aerospace.
Yeah. So we have so for this one, just put this over here. So once again, folks, this is MIT's page, but they have the core classes, and this goes into computer science and programming in Python, and this is something that you're not going to get in physics, I will say.
Well, it's.
I don't know.
It seems like it's not usually required.
No, it's not.
Which you would think it is, which kind of shocked me as well when I switched to physics, because when I switched to physics, I already knew programming, and I already took formal programming classes as well. But for some reason, this day and age, they still don't have like a mandatory programming track for physicists in most places. Like when I got into graduate school, a lot of the graduate students didn't know programming. I'm like, damn, you guys don't know one language? Which is kind of shocking to me, because I mean, like, modern stuff is all computers, right?
Yeah.
And you're going to use programming in any physics pretty much you're going to do, but for some reason they don't teach it formally.
No, they don't.
Kind of odd.
You kind of learn as you go, like with anything in physics.
Yeah.
I think it's like...
But there was the opportunity to do it as an elective at my school, which I did as well.
So part of my core in my undergraduate, we did have to take a computer science class, but it was part of the science department's core curriculum. But you could take any actually no, you couldn't take any, because the physics department had a class, but they taught Fortran of all things.
But that's because physicists actually use Fortran.
So, by the way, if you're an engineer, Python, beautiful. Like, it's going to have much more, it has more universality than Fortran, in my opinion.
Yeah. Yeah. Fortran is straight up for physicists pretty much.
Yeah. So if you decide to fail out of physics or just quit, Fortran ain't going to get you jobs. So we'll say.
It can.
Really?
They actually use it, in some places, but it is old as hell. So
I was just say, engineering wins on the programming side, I will say.
Yeah. And Python also is a big one for machine learning these days.
100%.
Seems like everybody and their mother does machine learning with Python. So that's also a big plus. If you know Python, then you can pivot to machine learning if that's of interest to you as well.
100%. There's also introduction to computational thinking and data science, which that is not really part of a curriculum. In physics, it's probably lumped into computer science, in a computer science course or elective.
I think we had a couple computational physics courses though.
Offered?
Yeah. In our graduate program.
I didn't. I took MATLAB. I skipped the Fortran. I said, can I just take MATLAB? It's at least a little more useful.
Yeah, people use MATLAB in industry.
Yeah, but I guess they also have materials and structures, signals and systems, fluid dynamics, thermodynamics, and propulsion. Those are the four. They call them engineering core classes.
And this is for the aerospace degree, right?
Yeah, but that on its own seems kind of. It's interesting because it's fluid dynamics could be its own physics class, really.
Oh yeah, for sure.
Yeah, so. But you will not get that in a physics core. But
no, you don't get fluid dynamics separately in physics.
And you do get thermodynamics, but you don't get thermodynamics and propulsion.
Right. So it sounds like their thermodynamics has the application of propulsion.
Yeah.
So you're going to be doing, momentum changing with the mass changing.
Yeah, which in physics you're literally presented a problem like an escape orbit problem.
Yeah, but it's real simple, right?
Yeah.
Rudimentary.
But there's also dynamics, which has some
Whatever that
crossover to
means.
physics, because dynamics is equations of motion. It's like it's physics.
Sounds almost too bare bones. I don't even know what that means because all physics is
dynamics.
dynamics. Yeah. It's like kinematics, dynamics. That's like all physics.
No, that is the analog. Dynamics would be what physicists take is classical mechanics.
Right.
That's our technically
Forces
our
and
dynamics.
stuff.
Yeah, our dynamics course.
Mm-hmm.
They also take a statistics and probability class.
Right.
And they have to take an introduction to probability class, which is or it's either or. And then finally differential equations.
Right. That's a huge one in physics.
But they only have to take one in engineering, which is interesting.
I only took one differential equation as well. Or you
Really?
mean partial differential equations?
No, differential equations. I took two.
Oh, I didn't. It just depends on your school, I guess.
Yeah, I guess so.
Because differential equations, I could see why you would do two, because there's so many different ways. Like, basically, the differential equations course, at least the physics one and math one, was just techniques for solving all the different types of differential equations.
Yeah.
I don't really see you needing two courses, because it just means you're going to learn more techniques, right?
Mm-hmm.
Once you've got a few of them under your belt, it's like,
Yeah.
okay, I get it. I'll use MATLAB or Wolfram in the future. Because nobody's solving these by hand, really. You mean you will, but if you're actually doing research, you're not going to do it again.
Yeah, that's where definitely part two is the fringe case stuff.
Yeah.
I mean, because you had that's when you dealt with sort of what is it called stochastic systems. And non-stochastic was differential equations 1.
And nonlinear differential equations.
Yeah,
or something?
nonlinear.
Okay.
Yeah. So you deal with in differential equations 2. I think you're introduced to more chaotic systems or how you handle second order, third order effects and stuff. Really cool.
Yeah,
stuff.
it's all well and good, but I'm glad I didn't have a second one. It's like I can just do that on Wolfram.
Right. But that's pretty much it for the aerospace one, and then you get into aerodynamics, structural mechanics.
These are actually the actual aerospace classes here.
Yeah, pretty much. You have to take a robotics class, flight development system. Yeah, it's a whole thing, but you obviously take some applied stuff for aerospace, but
yeah, we actually had a guy in my school who was a physicist who actually went aerospace engineering after his physics degree. So, that's the interesting thing about engineering and physics is they're so aligned in many ways that you actually can sometimes get a degree in one or the other and then go in the opposite way. Like if you get engineering, you can sometimes go to like a graduate school program in physics. We had a guy like that.
Yeah.
And then, you can either go start physics and then go towards the engineering side. So, there's a lot of play. And especially if you have certain classes that kind of align more with whatever the area you're shifting over towards, that helps a lot.
Yep, definitely. And I mean, they have. I knew. Well, we had a guy on the show that I think was. Shout out to Jesse, guest of the show way back in the day. But he was doing physics and aerospace at some point. He was like, "Yeah, I want to be an aerospace engineer." I'm like, damn, bro, you're doing too much. But no, he's he was also bright-eyed and bushy-tailed in that way,
right?
And he forewent all that and just decided to do math. But just because the impression that he got, I think actually he would have been the perfect viewer for this because then he could see which way he really wanted to go because he was still indecisive when I met him. But for physics, I mean, just at the standstill, you will probably take more than one calculus class. It looks like on top of differential equations, I'm sure they probably had to take Cal 1, Cal 2.
I'm not sure why it wasn't listed on there.
Yeah, it's very strange.
Because you can't just hop the differential equations, It doesn't make any sense. You have to take Calc 1, Calc 2, Calc 3.
Right.
And then you can take differential equations.
Right. I mean, in the I mean, I'm
So
jumping.
yeah, so don't think you're going to bypass calculus if you're going the engineering route. It's not going to happen.
Yeah, I mean, it's MIT, so maybe they're just like
They're assuming
that's a
you took it
given.
in preschool. Like the professors say, this is kindergarten.
Yeah, yeah. No, but in all seriousness, I mean, jumping ahead to there's another program called computer. So for some of you that might be debating computer science and engineering,
Mm-hmm.
it's they have a mathematics for computer science there. They have the same introduction to programming as with Python, which is kind of nice. But then they have specifically a class called mathematics for computer science, which I had a friend who took computer science, and I don't know why he was friends with us. Oh, I'm remembering now. He was friends with us because he was a roommate of another physics friend I had. But he was always talking about taking the math for computer science class, and he was learning discrete math or something. I forget what it was called.
Yeah, discrete something. Yeah, I know what you're talking about.
And he was just like, bro, this shit's
I heard
so
it's
hard.
hard. Yeah.
But then I'm like, as opposed to what? Continue? Like, are we talking about?
I never really investigated it, so I actually honestly don't know what discrete mathematics is.
It'd be funny if it was like just sums. How did you use sums? Some formulas?
I hear every time from people, though, it's hard. Like
in
discrete
computer
mathematics.
science. Yeah, I hear it all the time. Look, it can't be harder than anything physics already do.
I don't know. Yeah, everything's already hard, right?
Sorry, not to shit on computer science people, but I mean, I'm not sure what goes into. Apparently, that's a make or break for a lot of computer science people because I kid you not, how many times computer science people would come up to me and just be like, "Yeah, that's discrete math and sucks." So, hey, don't assume computer science is not going to already include math because it is.
Right. Computer science is definitely going to include math.
Yeah, he needed actually to take Cal 1 and Cal 2, and he didn't. He failed Cal 1.
Ah,
So
I see.
that's already a bad sign.
Right.
It's already a bad sign.
I didn't do that well in Calc 1 either, though.
Neither did I.
I got a C in that class.
Yeah, but look at where you are now, Terrence.
I know.
You did it, man.
Out of grad school without a degree.
No, but you got your bachelor's, so
Right.
So roaming the streets is a bachelor. But I mean, look, for me, I took a calculus the first time in the hubris of me though, because I was like, oh yeah, I'll take that honors one. It ripped me a new one.
Really?
Yeah.
Yeah, you said you got a C, right, as well?
Yeah. It literally was like, I'm gonna make my own hole, and it was just like, I was like, no, please, no.
Yeah, it's kind of because that's also like one of those first classes you take
Yeah.
from high school, right? You're just kind of
Sorry if my joke was a little too
Shell-shocked.
graphic, but
yeah. We'll put a video of you actually.
no. No, but it was literally just punching, like it was like in Dragon Ball Z, punching holes inside of me, like just. It was really bad, like it because especially it's a shock to your system if you've never seen calculus, because it's such a powerful tool and you want to go deeper if you're like a really deep learner, or if if you're somebody who tries to learn something deeply and really understand it in its framework, this is a subject that is it's developed for at least 200 years,
Probably several hundred years.
and it's condensed down into a 3-month course that you attend twice in a week. So the naivete of me to be like, I'm gonna learn all of calculus.
It's a good class though. I mean, calculus is one of those like
Yeah.
hugely important mathematics that just has a massive return on investment when you learn it.
Yeah. So what would you recommend to engineering kids, like to prepare, like basically prepare themselves? Like that is
For what? Calculus?
Yeah.
I mean, if you take it in high school, that's a good advantage. If not, then take it in college. No rush, I don't think. Yeah, just go with the flow of what your schedule is. If you take it freshman year, that's fine.
Yeah, I would say take it as soon as possible because then
I mean, whatever.
it'll make or break you, really.
Yeah.
Yeah.
Well, I don't want to say that. It will definitely show you if this is the field for you quite early, though.
That's what I mean.
Because you're going to have to know. Yeah, the math is only going to get harder.
Right. Well,
but if you get through calculus, then you're pretty straight, I feel like.
But I think calculus was one of the earth-shattering. That's what I'm saying. Like,
yeah, it's one of those ones that kind of shows you, like, do you want to go this way or not?
Yeah. Yeah.
And if you like it and you enjoy it, then I would urge you to stay on the course. Then,
just so you know, the first calculus you have to become. It's almost like you have to become Sisyphus. You know, you have to
the
imagine
guy holding the world up.
Yeah. Well, no, he's rolling. He's condemned.
Oh, he's rolling the hill up.
Yeah, rolling the boulder up a hill.
Oh, I see. This is the first bout of pushing the boulder up the hill. And now there's no going back.
Yeah, you have to imagine Sisyphus happy, as Camus said. To keep going, you have to imagine he's enjoying the pain. You know, so that's kind of what I'm telling you. Said? Well, yeah, it's kind of like it's all painful, really, but you have to find meaning in the labor of it.
Yeah.
You know what I'm saying?
Right.
Or at least you have already ascribed some meaning to the, like, I'm actually learning something really hard and it's rewarding in that sense. So please don't shy away from that. In physics, you will have to do 3 calculus courses.
Yeah.
As opposed
Same as engineering.
Yeah, I think a lot of them do have to take. No, I think a lot of them have to take Cal 2.
Yeah, and 3.
No, not Cal 3.
Think?
No, because in my engineering program there were no engineers.
Oh,
it cut off at 2.
Oh, I see.
Yeah.
Okay.
What about you? Do you remember?
No, well, my school didn't have engineering.
Oh.
So.
Wait, where? Which one? Oh, wait, don't say that.
My undergraduate institution.
Oh, okay.
Yeah.
Okay. That's interesting. I'm surprised that they didn't have that.
Well, we had another school that was already a giant engineering school, so I think they probably thought it was redundant.
They were just like, yeah, actually,
they're like, we're never going to get anybody.
We'll let them take care of it.
Right.
That makes sense.
Probably unnecessary.
Yeah, that makes sense. But yeah, usually the cutoff, from what I remember, it was mostly mathematicians and physicists at Calculus 3.
I see.
I don't know how it is at MIT. You'd have to check your program, but I think more than likely the cutoff is at 2. Calculus 1 is you're just learning how to do derivatives, and then Calculus 2 you're learning how to do integrals.
So you learn how to do integrals in both.
Well,
Cal 2 is like you just go next level on integrals.
Right. Yeah. But I'm saying, like, you're kind of in Calculus 1, when you get to it, you'll see it. The end, they treat it like on the next episode of Calculus.
Right.
And it's like literally the last maybe week or 2 of Calculus is spent on integrals.
Right.
Yeah.
Yeah.
So you get like a sneak peek, and you're like, oh, I'm gonna have to wait for this one. But anyway, so let's see what other Common Core they have here. So for the computer science and engineering, they have to take a robotics class, some communication network stuff. But here we go. The computer science requirements. You have to take computation structures, introduction to algorithms, fundamentals of programming, elements of software construction. So it looks like a bunch of software stuff and programming. And then
they got artificial intelligence and introduction to machine learning. I mean, that's a huge one these days. So
physics don't got any of that.
No, physics doesn't really have. We're kind of behind on the whole on the whole machine learning AI frontier in physics. We had a course in graduate school I took that was a really new elective kind of course on machine learning, but it was just a horrible class. I stopped going after like the second time. I was like, this is a waste of time. It's just so badly prepared. But yeah, that just shows you that physics is kind of like, I would say most schools in physics are kind of really behind in terms of machine learning, artificial intelligence. I mean, as we said,
go off, Terrence.
You don't even do programming, right?
Go off, man.
So, I mean, it's like, yeah, this is not very
would you say they're stuck?
Laid out in physics.
Would you say they're stuck in Newton's times?
No, I wouldn't say that because I mean they're doing modern
Nah,
stuff,
no,
you know. But they are a little behind. I mean, I feel like I was a little bit disappointed with the physics and like integration with computers. Like physicists are not really that well integrated with computers, although you know people do simulations and things and they use computers, but I feel like they don't use it nearly to the effect that it should be used. Like to me, I mean, that seems like that's like one of the ways modern physics needs to go because, you know, computers are just such a powerful utility. Why would you not be using them?
Yeah. Yeah, for sure. And I mean, we already use them in research. Like I had to pick up 2 languages. I mean, I don't know, no disrespect to Wolfram and shout out to Wolfram and the people at the Wolfram Project, but I did learn Mathematica and their little, it's not really a language. You think so?
Yeah, I mean, you do commands and things for it. I mean,
yeah,
so
but
kind of it's its own language.
I guess maybe it's not given as much respect as the others, but
yeah,
it is a computational. It's a computational language.
Yeah,
I mean, I would consider it.
It's like R or MATLAB, kind of.
Right, and I got pretty good at it for my Quantum 2 class, my Quantum Mechanics 2 class.
Right.
Because you have some really hideous integrals sometimes. So
I think I used Maple during that time.
Oh yeah, in our graduate class.
Syntax. Yeah.
That's very true.
Yeah, I was jealous of your Mathematica, but you paid for it or something, or you had like a pirated copy or something from one of your buddies.
Don't say that too loud.
I mean, perfectly legal.
All respect, all pays, all dues paid.
Scratch it from the record.
No, but I think no, I had a student copy version from my undergraduate.
Yeah.
That hadn't expired, yeah.
Okay, there you go.
Yeah.
Yeah, but you know, I would have had to pay for it, so I didn't use it, and I wound up using Maple, which is another kind of like similar language. You can do crazy integrals and things on it, so.
Yeah. So in physics, the programming is it's kind of like learn as you go. A lot of professors kind of have like their own. It's more context based to your research.
Yeah. And you learn specific techniques for your research. Like some people will do Monte Carlo simulation type stuff. In my institution, we did a lot of the Landau-Lipschitz-Gilbert equation, which was magnetic moments equation. Yeah, so it's real specialized. And then of course, like the nuclear physicists would use GN4, which is the simulation software for particle physics stuff. So it gets kind of real specialized in your programming.
Yeah. Do you think that's a good thing for physicists?
I mean, yeah, it's fine. I think physicists. I would like to see physicists have more general programming knowledge.
Yeah,
though.
Same. I would appreciate that too.
Because I think you can make more clever kind of experimental setups that way. All of the specialized stuff isn't bad. It's just like when you can specialize program, you can do kind of more interesting things. I feel like, and have more automated systems. And like one of the guys in my research group, he didn't know how to do programming at all, really, and he couldn't really do the data acquisition for the experiments that well. Like he was struggling with it because he hadn't done any programming before.
Yeah. Like shout out to my advisor, but in my physics, he would. In my physics group, he would actually do everything manually using like a data integration software program called Origin. So I became very versatile in it. And you can do command functions and stuff, but...
And you can actually program in Origin.
You can.
I think you can program C++ in there.
Yeah.
Or one of the Cs.
You can, but he preferred doing the manual, like, just to double check everything. But, I had a postdoc in my lab. They used Python to output graphs and sequences, and I was like, how did you do that? It was like a magic trick, because he was like, yeah, I mean, it would take my advisor like half a day to do what he did in like 2 minutes,
right? Probably
less.
Right. So programming can really up your game, I feel like.
So
yeah, definitely look into that.
So if you're a physicist, sorry, but you will not get much programming. If you love programming, you will not really find it in physics unless they offer a degree that's like specifically.
They have computational
physics. Yeah.
You can navigate towards that, and it will give you kind of an advantage too. I feel like, in some sense.
Yeah. And I think nowadays it's probably easier to like have or choose that as your sort of how would you say, your
Field.
concentration,
Yeah.
because it has more legitimacy. When I was
Yeah.
an undergrad about 10 years ago, it wasn't it computational physics. People would be like, "What the hell? Why are you going to bother with that?"
Yeah.
There was
Kinda.
it was still kind of like it still had this like I mean, dude,
It
there
just
was
wasn't
still
really that done.
yeah, it wasn't, and I mean nowadays you do have it has a little more legitimacy, and definitely the job market helps for it. Look, I'm not going to be I'm going to be upfront about it. A lot of physicists that graduate with their PhDs end up going to data science, or they end up
Right.
getting pulled into data science.
Yeah. And programming will massively help you on that front.
Yep.
If you can manipulate plots and data, I mean, you're golden for a job.
Yeah. So, and that's huge. And as somebody who's Terrence, both you and I have both been looking to job markets.
Yeah.
And that's a huge
Yeah, they
thing to
always
look
request
for.
that kind of stuff. Yeah.
And trust me, they'll test you.
And whatever the hell SQL is, you got to learn that too. It's on every fucking application.
SQL.
If you want an in on jobs.
Yeah. Just preparing you for the future here,
Or
kids.
SQL, however you say it.
SQL. Yeah.
I say SQL, but I think some people say SQL.
Yeah, it's and don't trust certification programs. I almost got duped into having a course.
Oh, really?
Yeah. Some MIT people were like, "You're in." I was like, "I'm in." I just put my name in and sent my resume. That was
Right.
it. And they were like, "Yes, but please pay us $1,200."
Oh, one of these
and
things.
I was like,
It's an MIT Ponzi scheme.
"How did MIT sign off on this? Like, they're using MIT's name to do programming." I was
It's
like,
actually like M1T instead of MIT. We're
It's
not MIT, we're M1T.
yeah, it's M lowercase I T.
Or one, it's like MLT. Lowercase L. MIT, no, this is MLT.
Oh no, that almost happened. That legitimately almost happened. So nice try, scammers. You're getting. It's not a scam. It's a legitimate thing, but there are ways
They pay
to.
massive amounts of money.
They just get people that are interested in supplementing their programming.
Yeah.
But anyway,
Don't pay for shit. You can get a bunch of courses online for free.
yeah. Speaking
do it.
of, MIT does those. So.
Yeah, exactly. Coursera also has some.
Mm-hmm.
Anyway.
But anyway, so it looks like they have their own advanced undergraduate subjects. So it looks like you can get a concentration, which you can also do in physics. But then we also have
Tried and true.
the
Electrical
tried and
engineering.
the straight up electrical engineering. And this is the one that's often most compared directly to physics.
Yeah. I feel like experimentalists and electrical engineers share a lot of things in common.
Mm-hmm.
You know, I like to call a physicist, basically when people ask me what's the difference between a experimental physicist and engineer, I say basically an experimental physicist is an engineer that never leaves a prototyping phase. So what I mean by that is, like, experimentalists, we have a lot of engineering type skills, like especially condensed matter if you want to really get closer even. So we can build things, you know, make like volt meters and stuff and all this kind of rudimentary equipment, but all of our shit looks like hell. We've got tinfoil wrapped on vacuum chambers and like wood blocks holding up entire experimental setups, and you know, pieces cut onto wire, like, you know, two wires is taped together with duct tape. Like,
Yep.
it, like if you go to a physics lab, you'll see it looks like hell. Like,
Yeah, it does.
it just looks like a hillbilly's version of like engineering projects. Whereas the engineers, you know, they'll do the prototyping phase like that might look similar, but then, you know, they'll eventually move on to the
Refine
actual
it.
production, you
Yeah.
know, and then have a nice, you know,
Refine
refined
it.
product, shiny and new, and it looks nice. So the physicists, though, once we're done with the experiment, we're done, you know, or we don't really care after
Yeah.
that, and then we move on.
It's a Rube Goldberg machine.
Yeah,
Like-
and shit always is held together like
Yeah.
by a thread, and
So
you've
people
got
are,
weird fixes, so you have to
Yeah.
like, I need to like hold this down while I turn this because the graduate student before did this in a fucked up way. So
yeah, everything works off of the lowest energy principle, like, and lowest cost principle.
what do you mean?
in physics, like in physics labs, like everything is just like if it doesn't need to be replaced,
Oh yeah.
like so you'll
'Cause
be
funding
using
is tight.
old ass equipment,
Yeah.
and there's all this it's
And people make there's always shifting graduate students. They make things in weird ways because graduate students are really not trained to do any of this stuff. So all your lab skills are all learned on the job. Like you don't study any of this stuff. Physics classes are all theory. There's no like hands-on stuff except maybe
the
lab.
lab classes,
And
but
that's
even
like-
then they're not.
Yeah, it's like barely, right? Like all
It's like,
your
how
skills.
does a ball roll? Like
Right. And then you're taking data on an Excel sheet. It's like most of your physical, kind of like hands-on skills are all in lab.
Yeah. By
So-
the way, by the way, that's
Real
one
lab.
thing. Yeah. In electrical engineering, I sat down in an electrical engineering lab just for fun.
Yeah.
And the amount of skills that they learned was like what physicists play with literally feel like toys.
Yeah.
Compared to what engineers have.
Right.
Because they're learning they're doing I was sitting in a circuits lab.
Mm-hmm.
And they were like actually learning all the components of circuits and
Right.
could actually, they were learning they knew how the board worked. It was kind of a smaller, more basic board, but I didn't know anything about it. And I was like, I can't tell you anything about what does what here and there.
You mean like the breadboards, the little training boards?
Yeah, like circuit boards. I'm not sure what they're called.
The breadboards are usually like the little white with the holes in it.
No, it wasn't that. I think it was an actual like silicon board.
Oh,
And they
okay,
were
so
messing
like-
with stuff.
Okay.
Yeah, it
Circuit
was-
board.
Yeah, it was an actual circuit board, and they were like playing with stuff, and I was like, "Wow, you guys know how to do this?" And they're like, "Yeah." And this was like a second year undergrad, and I was like,
Right.
"Shit!" And I'm over here in the physics lab, like we're all trying to figure out how a switch works, like one little measly little switch.
Right.
It's honestly pathetic. Like, I mean,
That's the other thing in
As a part of
physics
the
is
lab
like
thing.
versus engineering is like one of the things that really used to annoy me back in the day with experimental setups was, physicists know everything in theory, right?
Mm-hmm.
We know everything how to build it, kind of like just we know how to build stuff and we know what we need to build them, and then we'll write it on the paper and say, yeah, there it is.
Mm-hmm. Yeah.
But then as soon as you actually try to do it in real life, none of your shit works. And that's the thing that I think engineers have an advantage of, because in real life there's a lot of it works in theory, but then when you actually go to do it, your shit is not working.
Yeah.
It's because real life there's all kinds of variables, right? And sometimes the turn it on and turn it off again and then your thing all of a sudden works happens a lot.
yeah,
So you have to get that kind of intuition for experiment in physics, whereas engineering you kind of are given that through your coursework.
Yep.
So if you kind of like to get that intuition and everything through your course, then engineering might be the better way to go. Physics, it's like you kind of can get that if you're an experimentalist in the lab. If you're a theorist, you'll just never get it. And then you're just basically useless to do anything in real life.
yeah, seriously. And that's one of the things that I found annoying with my lab professor. He was just like, "I'm a theorist."
Yeah.
And he would just be like, "I don't know how any of this works." And I was just like,
Right. Theorists are basically the farthest away from engineers, if you want to talk about the farthest profession in physics.
yeah.
Condensed matter experimentalists, I would say, is probably the closest to electrical engineers.
Yeah, and I think actually most experimentalists, period, are
Yeah.
closer to. They have to know more programming, probably.
Yeah.
More. How would you
Yeah,
say?
some more than others.
Some more than others, but also just like. We kind of work at the ground level. Like our research, Terrence and I's research in condensed matter experimental physics.
Mm-hmm.
We kind of worked from like scratch, like things,
Yeah.
building things literally from
Right. We
starting
know all
materials.
the fundamentals of things, which
Yeah.
is where we shine more than engineers, because
Yeah.
we can build these things literally from scratch.
Yeah.
Like if I thought about it long enough, I could build a computer from scratch.
Yeah.
Like I would have to think about all of the moving parts and
Mm-hmm.
everything. Like I don't know it now, but I'm confident enough to know that I know the physics to be able to do that. An engineer, probably not. They
Mm-hmm. Right.
would have to look all the information up because
Yeah.
they don't have that fundamental knowledge.
Like, yeah, like I think, and electrical engineers, by the way, I know that they have to take a course in electricity and magnetism as
Yeah.
part of their, they have to take E&M, they do Maxwell's equations, so you will
Right.
see some physics, and in fact, electrical engineers also have to take quantum mechanics.
Oh, do they now?
Yeah, they
Oh,
do.
really?
Yeah.
Didn't know that.
Yeah, especially for like electronics. Like
Yeah.
if your specialization is in like fabrication and
That makes sense.
stuff like that.
Like nanotechnology
Device
and that kind of stuff.
fabrication, yeah.
Yeah, that makes sense. You're going to have to take quantum then,
Yeah.
for sure. Right, because that's all it is.
So if you're electrical engineering that wants to get electrical engineer that wants to get into like device manufacturing or
Right, like making like silicon dyes and
Yeah.
like really small microchips, transistors like in computers and things.
you will
You need
be
to do quantum.
you're basically going to be doing that. This is what me and Terrence are saying. Like that's the closest to physics that you will get as an engineer.
Yeah.
As an engineer.
And that's cool as fuck shit. I mean, that's what I really wanted to do for a long time as well, like device fabrication.
Yeah. And that to me was like to me personally, that was the biggest decision I made because you will touch on the physics, but you also have the application side.
Yeah.
And that was a big debate for me picking picking physics over electrical engineering. And because at the end of the day, what differentiates the two is physics is more scientific. It's less application oriented, and it's more about the knowledge acquisition as opposed to the, how would you say,
like getting a product created.
Yeah.
Like physicists, you'll hear them say all day, like when you ask them what's the application for this, they'll love the classic line of, "Oh, there doesn't need to be an application in physics. It's about the knowledge," which is true. But for me, when I say that, I'm like a little bit noisy. I'm like, there's always kind of an application. Like you could say, "Oh, I'm studying this to see if we can get further in like researching superconductors or something." Like that's kind of an application, but I see what they mean.
Yeah.
There's no direct application all the time like you would have in engineering with, let's say, like, oh, we're doing it to make a better battery or something.
Yeah. Which sometimes does happen in condensed matter physics. So that's what I'm saying. Like there is some overlap.
Yeah.
Like especially if you're a chemical engineer, let's say you're doing batteries tech stuff.
Yeah.
Then you probably actually, what would a chemical engineer kind of physics you would need to know? Stat mech probably. Statistical mechanics.
Maybe.
Yeah.
Maybe even quantum and chemical engineering, depending on what you do.
Yeah, I had a friend who took who did chemistry. No, was it It was he had to take like a quantum chemistry class, which was quantum 1.
Yeah.
Yeah.
Well, yeah.
Yeah. So good luck to you. Good luck to you. Good luck to anybody taking quantum mechanics if you're an engineer.
Yeah.
Because
it's tough.
It's tough, and it's even because if we as physicists are scratching our heads.
Right.
Actually, you know what's interesting, and some of you probably have a better intuition when you're taking quantum applied, because now that I think about it, chemists, like the chemists that I've talked to, I didn't have a good concept of quantum until I got to graduate school.
Yeah, same.
Because it really honed in the orbital stuff.
Yeah,
you know what I'm saying?
Oh, for chemistry.
Yeah.
Yeah, because that's kind of crazy how
that's
long
where it integrates.
takes.
Yeah, because that's where it integrates your previous knowledge about like chemistry and orbitals.
Yeah, it's kind of a funny aside. Like, you know, you learn all this SPDL, whatever the fuck shit in chemistry, and you're like, what is this, man? You're like, what is this? And you only learn about really that knowledge when you get to quantum, I feel like. Like you finally start to understand and put those pieces together. Like, oh, this is how they got all this stuff.
Yeah.
It's kind of cool.
I know.
I think I only put those pieces together, you know, in graduate school quantum.
Yeah. Same here, yeah.
So it just shows you why they have to just tell you to regurgitate it when you're in undergraduate, because it takes all the way to graduate quantum to really get to that understanding. Kind of crazy. Anyway.
It is. But, and I mean, like, you'll see some of that in electrical engineering, though, I was going to say. You don't necessarily have to learn all the SPDF, but sometimes they will talk about like d orbital stuff, and you'll learn more band theory, which is called, which you do see a lot in condensed matter.
Yeah, I mean that's bread and butter for condensed matter.
Yeah.
And that's all about what's an easy way to characterize that? Would
Like
you
band
say
theory?
one? Yeah.
How electrons
people-
behave in the material.
Material.
Yeah.
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 So it's like an easy map, but it is hard. And if you're more interested in that, then physics is for you. If you're more interested on the applications side of it, then maybe engineering is for you.
But you can have your cake and eat it too, in both sides, really, in some sense. Just a matter of like,
which one you prefer more? Do you think it's like a 60-40? Which one?
yeah,
Which one
I think
edges out?
so. Because I mean, you can lean real heavily on the physics side as an engineer, and vice versa. You can lean real engineering heavy on the physics side. I mean, I feel like we kind of leaned real engineering heavy in some sense on the physics side.
Yeah.
You know, so it's like if you just want to have both worlds, go with the one that you're kind of more passionate about, and then if you want to kind of scoot a little closer to the other side, you can do that. I mean, that's literally what me and Juan pretty much did here as experimental condensed matter physicists. I mean, we're very in line with a lot of engineering stuff.
Yeah. Yeah, I was going to say that electrical engineers have an added benefit of taking an actual circuits electronics class, signal processing.
And I would highly recommend you take electronics if you're a physicist and you want to go, like, let's say if you're interested in like me and Juan's route, kind of experimental physics, but kind of leaning towards the practical engineering side in some sense. I made the mistake of taking condensed matter over electronics, which I kind of regret. I really wish I would have taken electronics more because I still don't really have a great conception of circuits as much as I'd like. Like,
Same
I really wish I learned more about like op amps and like, more about like grounding, like to understand really grounding.
Yeah. I bought like
some of the other stuff.
Yeah, I bought a little circuits book because it's all differential equations.
Yeah.
At the end of the day, like I looked at the book, the subject matter book, and it was just like, and that's kind of the opening line. It was just like, all you really need for this is differential equations, which is just calculus, and actually that's one of the core classes. So I mean, they're not lying about that. You just use differential equations, but they're nasty, very nasty string, because there's so many components that require you do big derivatives for long strings of algebra, because you have circuits that are like, in physics we have Ohm's law and whatever. We have resistors, and anyway, there's a certain representation that you can put when you need calculus to solve this huge circuit board.
Right.
I can't remember the details of it, but
I don't know.
But yeah, it's apparently disgusting.
I'm sure it is.
And you have to use like Kirchhoff's rules, and you have to like circle the circuits, and you have to do its own separate calculation, and then. But
yeah, understanding circuits is really useful if you're trying to go into like electrical stuff.
Yeah, and by the way, I say all that like I know what I'm talking about.
Yeah.
But this is like stuff that we're introduced as physicists. We're all introduced in theory because.
What?
Like I was just naming Ohm's law is one of the things that we're taught.
Mm-hmm.
We're taught very basic, rudimentary electronic stuff, right?
Yeah, but also a little bit of advanced stuff in some sense.
What do you mean? Because that's.
Well, I guess
do you
not.
think that's enough to survive? Pretty much.
Yeah, I think it is because
It's
we
like
can
the
derive
bare
a lot of the stuff.
Sure.
Especially with condensed matter as well.
No,
you can couple with condensed matter class.
Well, I was saying like straight circuit stuff.
Oh, okay, yeah.
Like Ohm's law and what is all the Kirchhoff's
I'm not sure
rules.
how much really more engineers learn than that. They learn mostly like how to build circuits. They don't learn the fundamental stuff.
Mm-hmm.
So our fundamentals could, in theory, I think, carry us forward.
Mm-hmm.
But it's just that we don't know all of this stuff that's already known of like how an LRC circuit really works in actuality and like how to combine those different elements. Like I know what an LRC circuit is. I could probably derive the properties and stuff and then make more out of it. But engineers have a more like quicker recall of these things because they actually use this stuff.
Yeah. And Terrence Snow's an engineer, so he has a very good pull comparison.
Yeah.
Well,
kind of. He's still a physicist, but
is he? I thought he was a full engineer.
He's a physicist. He went the physics route, but he's definitely like more of an engineering mind, I would say.
Oh, gotcha.
But he got the same education as me, pretty much undergraduate wise.
But he like went straight to engineering post physics. Oh,
pretty much. Yeah.
Dang.
But he's always been an engineer in some sense.
Engineer at heart.
Yeah, for sure.
Well, maybe he's a good example of maybe he want to do. He was a guy in physics that wanted to do engineering more.
100%. Yeah.
Gotcha.
Yeah.
Okay.
He just couldn't get into the engineering school. So. Which is hilarious though, because he's smart as fuck. I mean, he's like probably better than any engineer that I've ever known. So it just shows you it doesn't really matter sometimes. If you can't get in, make your way. He's a great example of make your way.
Yeah. Do you think he would have, if he could go back, he would have chosen engineering?
Yeah, for sure.
Yeah. Okay.
He wanted to choose engineering now. He couldn't do it. So he'd go the physics.
Well, because I'm trying to wonder if physics was actually rewarding for him.
It was, I'm sure, because he got more interesting knowledge that he might not have gotten in engineering.
I see.
Some good connections as well,
Sure.
He gets to work on cool scientific projects.
Yeah.
Maybe instead of like working in like a IBM facility or something.
Mm-hmm.
So yeah, I think he probably got a lot from it.
Yeah, I wonder about that, because for me, it's like, do I have any regrets about choosing physics over engineering? Yes.
Yeah, I'd probably say the more regrets of just having a normal life.
Yeah, exactly.
With a decent salary.
And that is one huge thing that
that's probably a giant part of choice between physics versus engineering. Mm-hmm. Because you can just get a bachelor's in engineering and you can be making probably $100K within a few years.
Speak on it, Terrence.
And then with physics, I mean, don't hold your breath pretty much when it comes to like, when it comes to like academia, like the odds of you getting an academic job are just slim as fuck in physics.
Yeah, but let's say you're one of these people that are like, I like physics and I like. Let's say I like experimental physics. Yeah. What are the prospects of me finding a job?
I mean, any job you mean?
Well, let's say it's you want to do more like R&D kind of stuff.
You can do that.
But who do you think has a better chance?
I think engineer.
Yeah.
Engineer has a better chance. Engineer has a better chance in the job market pretty much in general over a physicist. But that's not saying that a physicist can't be valuable. It's better if you have more skills that are marketable though. So if you want to be in a job like, let's say an R&D or something, then it'd be nice if you had some of those skills that the engineer would have as well as your physics background. Mm-hmm. So engineer will prepare you more like out of the gate. Like as soon as you get a degree in engineering, you're pretty much set to go to get a job.
You're the belle of the ball.
Yeah.
Like in the job market, 100%.
Yeah. People are like, they want you bad.
Clamoring. Yeah, clamoring.
Yeah, we want you now. But the physicists, they're kind of like, huh? Yeah. They're a little bit more confused by you. People don't really know what physicists do necessarily.
You're the person at the ball with glasses. You're the ugly duckling.
Right, but if you take
the
glasses off and let her hair down, I mean, damn, you're like, oh, okay.
Wow.
But you have to get the person that's going to want to actually see that.
But physics just has a better personality. No.
Right.
Well, I mean, I will say physics does have more of like, you do have to put in a lot of hours.
Yeah.
Just because the amount of math that we do at the end of the day. I mean, we do all the way to calculus 3.
No, we do more than that.
We do calculus 3 plus differential equations. Yeah.
Yeah. Okay.
And then,
and possibly more.
Yeah, you basically get a math minor on the way to physics, which I don't think you get in engineering.
No.
So,
like, I was probably 2 classes away from being able to get a math major in physics. That's what a lot of people do. They just double major in math and physics because they're like, I'm only 2 classes away. I mean, might as well.
Very true. I think I was kind of in the same boat because I needed to take was some kind of math class. Maybe it was discrete math. There was some math class that I had to take, and I was like, you know what? I'm done with this. Because they were talking about graphs, and I was like, we're still doing graphs? Like they were talking. Well, they were talking about real space maps, and I was just like, I'm done with this. give me the application stuff, because physics is already math heavy, and I was just like, nah, I'm done talking about this wonky theory stuff.
I just wanted to get out of school. I'm like, I've been already here for like a decade. I need to get the fuck out.
But yeah, and also in physics, you have what feels like more coursework. You have a lot of
you have less of a life for sure. I feel like in physics, engineering you can kind of go out and party every now and then. In physics, it's like don't hold your breath.
And I will say that that's mostly because of the culture in physics compared to engineering. So the culture in physics versus engineering. In physics, it's very much. It's still very much a. It's like a pain. It's a pain mentality.
Yeah. There's more normal people in engineering. Let's just straight up be real.
Noble?
Normal.
Oh, they said noble people. I was like, whoa. Is he calling physicists immoral? No, there are more normal people in engineering, and I have, meaning in the sense that they're a lot more tied. They've touched grass, is what we're trying to say.
There's a little bit more of a work-life balance in engineering.
Yeah.
It's still a little bit crazy, but less so than physics. Physics is insanity, basically.
Mm-hmm. Yeah, because I have a friend of mine who came from engineering into physics, and he was just like, "This is insane."
Yeah.
He's like, "This is insane." He was sitting we're studying for a quantum exam, and he was like, "Dude, this is crazy. I'm gonna go back to engineering."
But the nice thing a little bit about undergraduate or about physics is that it is kind of so insane, even undergraduate, that I feel like the transition into grad school is probably a little bit more diminished than somebody who's coming from a different graduate school program or for an undergraduate graduate degree in another program. Like,
right.
Because everything's insane at the PhD level, pretty much. Mm-hmm. But if you're already kind of operating at an insane level already in physics, then it's a little bit less of pain as soon as you go to graduate school. Yeah. Because you're already used to kind of some of that.
It's like, you ever see your car, like the car is like RPM thing? Like in physics undergrad, it's like you're at maybe, let's say your car starts redlining at 7,000 RPMs. In undergrad physics, you're at 5.
Yeah, you're like at 5K.
And you're like, oh man, this is hard, and I'm holding it there.
Right.
But in graduate school, you're starting a red line. You're like 7,000. Holy shit! And the car's shaking. You're just like, ah.
But other people are kind of like the engineer may be like 3K.
Yeah.
And then they go to 7,000. They're like, oh my God, what is this? It's more of a shock.
Exactly. Yeah. The amount of the change of inertia is just like, it sends the skull, the skin around their faces to the, like, you ever see those, like,
it's like pulling their skin back. Just from the sheer G forces. Yeah. So if you're more of a masochist, go physics. That's the bottom line.
I 100%. That is not something that we're kidding about. No. I know we're laughing, but it's because of the residual pain that's there.
Right. And nobody ever really believes it until you're in it.
Yeah.
You'll see. It feels kind of pathological, but I mean, that's what it takes to get there. If you want to be at that level, you got to operate that level.
Yeah, I mean, we literally did an episode of how to be like a God tier or Chad tier physicist. Mm-hmm. And even the professor there said it's 5 years of just straight, like, basically hyperbolic time chamber type fucking training shit.
Right.
Yeah.
Yeah, you're busting your ass for real. You will bust your ass. I don't care who you are.
I don't think I've ever met an engineer that's like, you're going to bust your ass. It's always just like,
yeah, they're kind of chill.
Yeah, it's always very chill. The professors I've met are super chill, and they love, if anything, they like physicists.
Yeah.
Because they have a
respect for physicists. Engineers have a pretty high respect for physicists, I feel like. So they're like, yeah, like, you guys really know what's up. Like, yeah.
Well, the professors do, but the students don't.
No, they do.
The students
have a respect for physicists?
Oh, the students, the ones that I met in my undergrad, were always just so like, ha ha, like, we're gonna make more money than you.
Oh, right.
And I was just like,
yeah, the engineers do win at kind of the end of the day.
Yeah,
Because the value of an engineer bachelor's degree is definitely more valuable than a physics bachelor's degree.
Yeah, let's
A
draw.
PhD, though, in physics
is highly valuable.
Right.
But a bachelor's in physics is lesser value than an engineering bachelor's degree. For
Right,
sure.
across the board in terms of like effort values. Let's put it on a scale. So effort value on the Y, and then hold on, maybe
it's gonna be hard to draw.
Actually, this is kind of hard to draw. What I'm trying to compare actually are the degrees versus effort.
Yeah. So you're going to put more effort into a physics degree, and your degree is going to be worth less in bachelor's.
Yes.
So really in physics, you're going to be doing it for the love of the game. Like the knowledge is the key.
Mm-hmm.
So if you just love to learn and you love knowledge, go physics.
Yeah.
Engineering, you're going to have a lot more. You're going to have a higher value for lesser time or effort as well. So if
you probably will sacrifice real understanding.
Yeah. If you're not as concerned about actually knowing all the fundamental knowledge and stuff, then go engineering. You'll have also more of a balanced life as well, probably, because you can kind of have a better starting salary, and you can have more opportunity to make a family and that kind of thing. So engineering is probably better in that sense.
Mm-hmm.
But then when you get to graduate school, engineering is kind of stupid to go to graduate school for. Like people kind of scoff at you if you go to graduate school in engineering. It's kind of like, what are you, a physicist? So it's kind of like, you can do it, but it's kind of weird. It's odd.
Yeah, we know one guy that went from physics to electrical engineering.
Yeah. Yeah.
And I asked him one time, I was like, hey, what the hell are you doing? How did you, how was the transition? And he was just like, well, like you basically, it's like you take on a more specialized, like you get really, how do I say this? You just get hyper specialized in one thing for electrical engineering. So you become like, let's say it's robotics. You just become really good at that robotics thing.
Right.
Or in physics, we were talking
same thing in physics.
Well, we were joking about it a couple episodes ago, where it's like in physics, grad school is like New Game Plus.
Yeah.
It's
that's the courses though,
right? But in engineering,
because you're still doing the hyper specialization in your research.
Well, no, in engineering, it's basically like you're trying to now you're taking let's say you're an electrical engineer.
Yeah.
Now you're taking quantum mechanics at the level that a physicist would understand it at.
Mm-hmm.
Because you need to.
Right.
Because you need to understand how devices or transistors or how would you say field effect transistors work.
Right. So an engineering graduate school is basically approaching a physicist.
Right.
Yeah. So it's like if you really are an engineer and you thought, I wanted this life of, the good life and the money, but then you're still feeling sad, like, I really wanted the knowledge, you can just go to graduate school and you'll be fine.
You can. Yeah, you can. Yeah, legitimately.
So that's why these things are not set in stone. Like there's ways to get to where you want.
Yeah.
And even if you're not completely sure, you can just hop into something and then you'll eventually get your way there.
Mm-hmm.
But then, what was I going to say? With physics, the physics, kind of the golden path for physicists is to go to graduate school. Like, a lot of times you're assuming that most physicists are just going to go to graduate school and then get the PhD, and then you're kind of a real ass physicist once you've got the PhD.
Yep.
Like me and Juan are kind of like scrubs in the physics game because we have no PhDs, which is kind of like, yikes.
It's like
not yikes. I mean, I'm exaggerating, but it's kind of unusual
in the physics realm.
Sense.
In the physics realm, you're kind of looked at as like
you didn't make it.
No, sort of, but I feel like it's kind of like it has this like it feels like they treat bachelors as an elementary student.
Yeah.
Like, you're kindergarten.
Right.
And then, and then middle school is like, I don't know, master's or something.
Right.
And then high school is
PhD.
PhD.
Yeah.
Yeah. It's so stupid though. It's so stupid.
Yeah. I mean, it is what it is though, right? It is what it is.
That is the culture, but that gives you a snapshot of what the culture is in physics.
Yeah.
It's like,
physicists prize knowledge first and foremost. Like they want you to be the shit in terms of your understanding and depth of knowledge.
Yeah.
Engineers pride you getting this shit made and getting this shit, fixed.
Getting it done.
Getting it done. And, that's it. Like companies just want you to make sure that shit works, looks good. Here's a bunch of money.
Yeah. Make it work. Turns on. Good job.
Right.
Here's a raise.
So that's the two paths, I guess, pretty much.
Yeah, pretty much. I mean, there were a couple others on the list that I was debating talking about. Like, there's civil engineering, there's mechanical engineering, there's also nuclear science engineering. But
I'm not even sure what that is.
Huh?
I'm not even sure what that is.
Well, let's give a little quick. Let's see what they got. Let's see real quick. I know this is the show's coming to a close here, but for the nuclear science, they say, oh, okay, nuclear science, you have to take physics 3, physics
Whatever
1, physics 2,
means.
physics 3.
Is that just modern physics?
Yeah, I guess so.
Okay.
Differential equations is it's kind of standard. Thermal fluids engineering.
Is this for like fusion reactors, fission reactors?
I
and
guess
stuff?
so. And then required core subjects: applied nuclear physics, nuclear systems.
Yes, this is probably like related to
neutron-
energy, I imagine.
Neutron science, reactor physics, engineering of nuclear systems, fusion energy.
Right.
Yeah.
So if you want to work in like nuclear reactors and such,
Then I guess this is useful because you need to know like meltdown conditions and all this kind of more physics realm kind of stuff.
Yeah, it'd be funny if you're like, I want to be a nuclear engineer, and you decide to do physics. It's like, oh no, this ain't it. Like, it really isn't. Like,
Yeah.
physics is not going to do what this
Not
covers.
like those systems, no.
No, not at all.
but I mean, physicists like me and Juan, we do no nuclear physics stuff. So
I mean, I know a good bit about, nuclear radiation and fission and fusion and all that kind of stuff. Nuclear reactions, decays, but,
I don't know anything about like.
how to build reactors or anything. I know there's a steam engine.
Yeah.
So I could probably build one from first principles if I thought long enough, but that's the difference between engineers and physicists. The engineers they have all the tools, the modern tools and all these things to already know what to pretty much do in the reactors and how to build them and how they work
Like for me, I'd have to come up with it.
with a pencil and paper.
Yeah, no, I was going to say that, well, just touching on the last couple, like mechanical engineering, it's they have to take mechanics and materials, dynamics and control, whatever that means. I think it's just dynamics and control is they model, analyze, and control dynamic systems. It's mechanical, electrical, and electromechanical systems, actuators, sensors. They have some linear algebra, Laplace response, poles, and whatever that means. Just a bunch of electronics. It's kind of like a jargon of stuff, really.
Yeah.
But man,
Okay.
it seems more like you kind of get in engineering. It just seems to be like a running learn as you go. You don't really go too deep into things.
No.
Yeah.
And it's mostly for that specific kind of area.
Yeah.
Like they just wanted to know.
They want you to know about that particular
Yeah.
area.
Physics is more holistic.
Yeah.
You're literally trying to understand the universe.
Yeah, you're trying to understand the mechanics of everything, basically. That's why the physicists have the depth of knowledge, and we can build all this stuff and understand all these things from first principles.
Yeah.
But, we can't just be thrown into a reactor and just know what to do. Like,
Yeah. It's like the joke where you're like, I need a doctor.
Right.
And it's like a physicist on the plane. He's like, he's choking. And just like, well, all you have to do is remove the object. from the
Right.
set.
The problem is solvable.
Problem
In theory, there is a solution.
There's a solution. Actually, here I know how to solve your problem. He's choking, clearly.
Right.
But anyway, that's what's funny? I was thinking today. I know this is an aside, and we're going to close the episode, but we'll close it on this. I was thinking a physicist would be good to help rebuild society.
yeah, for sure.
Like I was thinking, the places that you could maybe get free electricity from
Yeah.
would be. I was thinking, the ideal thing to look for is like a waterfall or something.
Yep.
Because then
That's one way.
you could build a
Hydroelectric
Yeah.
mill.
because easy. Because the hard part would be finding a magnetic material or refining.
Well, you don't
magnetic.
need to have a magnetic material for that.
You don't? You wouldn't do it that way?
Let me think.
Because I was saying you
Well, I'm
could
saying
generate
you could-
current.
Okay, you're saying to make electricity
Yeah,
specifically.
yeah,
Okay, sure, yeah.
Yeah, you could generate current by just using the mill
Mm-hmm.
and moving a bar magnet
Yeah.
and just
And then making kind of like
a rudimentary,
An inductor or something like a
Yeah.
coil, and then
pretty much.
yeah.
Would there be any other way you would do it?
We talked about this I think before.
Yeah, we did an episode, but it was
that would be my number one way, probably hydroelectric, because it's just
it just makes the most sense, right? I mean, like you can't make photovoltaics. That requires a lot of previous knowledge.
and mega refining
Yeah.
tools. Yeah.
So I feel like hydroelectric is probably one of the ways to go. I can't really think of anything else right now. But yeah, I feel like a physicist would be.
Unless you ended up unless you're one of those unique places in the world that are geothermal sites, right, where they have steam
how
pockets.
do you make? You're saying okay, then you'd make steam.
like a steam engine type deal.
Yeah.
Yeah, you could do that. That kind of powers a turbine or something.
You'd boil
Yeah.
you boil alive, risking the.
Huh?
You'd almost boil yourself alive, like trying to get the.
Well, that's why you get the engineer to make it. You're just here for the theory, the calculations,
Yeah. So a physicist is useful in that way. Really, a town ain't big enough for two physicists in that kind of society. You don't think so? They probably need one physicist is enough.
Probably, yeah.
They're like,
I feel like if we were like playing a Civ game or something like a RPG kind of game, like you would definitely want to invest a lot of points in your physicist,
right,
to come up with your tech really quickly.
Yeah.
But you definitely need workers and people because the physicists would be shit at building it.
As long as they can actually detail the work, then the workers are better to actually execute the work.
Yeah. Pretty much. I'm
Yeah.
sure.
And the engineer would be better because they would know how to do the more advanced things already. The physicist would be deriving it from scratch, and it would take a long time. So you would definitely want to buy the physicist first, though, or like buy him like in the beginning somehow.
to build your society. Yeah, for sure.
To put all the sketches down and lay everything out.
Yeah. And I mean, like, to synthesize it further, I think I'm kind of biased here, but physicists, I think, are the purest form of a researcher. Like, in terms of being able to model things mathematically, like, in a lot of ways, like Tara's kind of alluded to earlier, every field kind of approximates math modeling, and physicists are kind of already trained to do that from the beginning. So, you know what I mean? That makes sense.
I think, not sure exactly.
Like math, what particularly? I guess math modeling.
Well, you just mean physicists are good at making models?
Yeah, or like just approximating, just knowing how to like match data, or like trying to come up with things from first principles.
Data.
Yeah, manipulate data. Yeah.
That's basically what a physicist is to me.
Yeah.
Being able to think really well from first principles and to be creative problem solver to figuring out how systems work. That's it.
Yep. So there you have it.
Yeah.
There you have it. Is
That
there
wraps
anything
it up,
else? Yeah. Anything else you would want to add to that?
I think that's it. I mean, leave in the comments. Would you? What side are you leaning towards? Have we changed your mind about anything? Would you rather go engineering or physics? Tell us below.
Yeah. Or anything you learned that was surprising that engineers do. Yeah.
Or if we said some wrong shit, engineers, then
Oh
let
yeah,
us
if you're an
know.
engineer, maybe you can correct us.
Yeah.
I would love
If you're
to.
like, that's not it at all.
I would love to have an engineer, but unfortunately, they don't have the. They're too busy buying model cars,
You need
driving
an engineer on the show
driving Lambos, and yeah.
and having hot wives and husbands.
Exactly. While we're over here with T-shirts from the bargain bin at Walmart.
Yeah, I literally have like
5 shirts.
Yeah.
You've seen them all on the podcast.
Anyway, folks, we'll see you later.
All right, guys.
Make sure to like, share, comment, subscribe.
Check out Eigenbros.com, Eigenbros on Instagram, Eigenbros on Twitter, Eigenbros2 on TikTok. And then patrons, guys, we thank you guys so much. Once again, check us out, patreon.com/Eigenbros if you want to join up. 30-minute podcast, audio podcast every week.
Sure.
And, yep, we
That's
will
it.
see you guys next week.
Peace.
Later.